Alrighty, we are the last home stretch. 2 weeks left. I apologize again. I recorded Mod 11, and then when I went to go play it back to make sure it worked, it basically was just me talking. So you didn't even get to see my screen. So as much as I love my face, and also as much as I love hearing my voice, I didn't think that was going to be very conducive to this course. So again, like I said, don't worry about being penalized or anything. I'll go ahead and make sure that y'all are taken care of. I'm just going to put it up in the very beginning because we're getting to the part to where basically these last two sections are going to be kind of, a little bit more active in regards to that. So they're a little bit more, I would say they're a little bit more technical. So now we're getting to the actual nitty-gritty stuff of actually being an administrator and what we can and can't do. So let's go ahead and talk about chapter Mod 11, which will be 22 and 23. Mod 12 will be 24 and 25, and then we'll end the semester with that. That'll be next week. And then again, make sure you got all of y'all working on your final projects. If you have any questions, please go ahead and make sure you let me know. And just keep working on them and everything. Like I said, I've really reduced the amount of actual activities, so that way y'all can really focus on that. So let's go and talk about this. So the first section is going to talk about a couple of things. We're talking about LDAP, we're talking about FTP and SSH. So LDAP is the lightweight directory access protocol. FTP is the file transfer protocol, and SSH is going to go ahead and be the secure shell protocol. That's going to be for the secure login. So let's get into it. All right, so lightweight directory access protocol. This is going to be your DHCP service for the Linux environment. It's a directory service, looks like Active Directory for the Windows side, and it's based off of that. Actually, my Active Directory is based off of LDAP, and the most common one you'll see is going to be Open LDAP. Now, by default, though, Open LDAP is not installed, so you have to install it manually using the Open LDAP server. And again, you'll do yum install Open LDAP server. There's a couple configuration files you're going to look at. It's going to be slapd. I know it's kind of sound weird, but it's going to be slapd.conf and Etsy in the Etsy Open LDAP folder. Okay. And the name of the Open LDAP server is called slapd. So these are the kind of key terms you have to kind of understand. There's actually an object, you understand like an attribute, you have a schema, and these actually all kind of like go into how you design your enterprise structure. So the object's going to be any entry or record that's going to be in a single item. The attribute is going to be what components does that object get, and then the schema is going to be defining the attributes and objects together. So this may be the accounting department or finance, okay? That can be the schema, or these are just going to be users, okay? And then the LDAP data interchange format, this is used to create LDAP objects, and what we use this for is, along specific values for these attributes. So some other key LDAP terms, you're going to have the DN, which is going to be the distinguished name. That's going to be your distinguished name. Then you also have the CN, which is going to be the canonical name or the common name. That's relative to the object. It might help. So you can have CN is going to go ahead and be Bob. And then the distinguished name can also be Bob. Then you have this thing called the System Security Service Daemon. And what this does is, this actually is what is the authentication provider for user accounts. So when they log into their account, it's going to use the SSSD to authenticate to the LDAP server, okay? Because remember, the DC is the Active Directory and domain controller are the ones that actually handle the authentication process. So there's two different ways you can actually go in structures. You can have what's called the mirror company domain name structure, or you can have the mirror the company's geographical location. So you can split this up between whether it be the US and Spain, or this is going to be OCS, and you have sales, English stuff. Then you break it down even further by the people, okay? So here's what we're looking at, the slapd.conf file. These lines import the LDAP schema. So this is where we get the LDAP schema. You can't, they could be placed in LDAP compile, but they are large. So we don't want to go ahead and import them. So what we do is we go ahead and actually import them instead of having to download them. And it's better to include these, to use include statements, because that way we can actually make sure that it's being actually taken care of. So the way we first do that, we need to go ahead and verify that there's no problems with the configuration file. And just like you're seeing with some of these other services, there's actually verification commands that have been created for these actual services. We have slap test, tac-u, tac-v. So the tac-u right there, the v is going to be verbose and give us an actual verbose verification. And then the tac-u right here is going to go ahead and actually verify that with the users. And then once that actually gets verified, we start the Open LDAP server using the correct technique for your distribution. This can be things such as, system SCTL, like we've been using start LDAP or slapd. You just got to figure out depending on which one it is. For most Red Hat and everything, you're going to be using system CTL a lot. Using LDAP search, this is actually very useful to verify that Open LDAP server is responding to queries. This way you can make sure that there can be queries happening. Remember, we're talking about authentication queries, client queries, stuff like that. So you have the use simple authentication, search base, and capital S determines the return order of the values. So let's go a little bit deeper into understanding how to create an Open LDAP object, okay? So to create an object, we look at the, first to create what's called the LDIF file, which you talked about that earlier. This is the interchange format, and the format of this file is always as follows. You have the DN, which is domain name, the DC, which is domain controller, okay? The description, the object class, and another object class, it's DC object, it's also an organization, and then the organization itself is OCS Incorporated, okay? So from there, we can actually define schemas. These define the object types and which attributes they make up those components. So we have this, the score schema file, which is going to be the schema tac, actually it's going to be core. That's actually a mistype. It's core schema file, which is actually an Open LDAP and etc. And this is what an actual schema looks like. So we have a class. It's called organization. We have structural. They may have a user password. They may search guides. See also business categories, postal address, international ISDN number, telephone number. So now we're seeing the information is going to be collected for each user. But they must be a part of the organization, or O, okay? So to add the content of an LDAP file into the LDAP directory, we have to execute what's called LDAP add. So we can actually do commands. We can do LDAP.txt. So here's actually it right here. And then we run LDAP add tacx execute tacd, this right here. And then it's going to ask us for the LDAP password. Yes, there actually is going to be a separate password for the LDAP directory. So unlike the, you can configure this in Windows, but a lot of people don't do that. You can configure a separate password in there. So then you also have database changes. So if you need to make any database changes, you can do LDAP modify, LDAP delete, or slap index. An index used to make it easy to find data. So if you want to go and make sure you can create an index, make sure once you get everything set up, create an index. That way it's easier to find everything. And all these are depending on like whether or not you have also the ability to, because you can actually set access controls on this too. So to delete an entry or object, you don't require the LDIF file. Excuse me. And you have to specify on the command line what you want to delete. So notice right here we have LDAP delete. The UID is named. The organizational unit is people. The domain controller is OCS.com. And then we're going to do tacx, tacd, cn root, dc, os, dc.com, tacw. And it's going to ask us for information. And again, we can go into the LDAP delete and look at all the actual options in there. I'm sure your book gives you some of the examples. But I'm not going to go too deep into this. This is not an expectation for you to actually be able to successfully do because it requires an actual server. So next thing you want to do is provide a better way than Slapcat to view details, open LDAP, so you can do LDAP search. So X means simple authentication, specify the base to search from, and then UID is what attribute to return. So I want to go ahead, I want to use simple authentication. I want to specify the base to search from, which is going to be people. The DC is going to be OCS, DC equals com, object class equals account, and then present me the UID for the attribute, okay? And again, you can set up access controls. So you can set up an LDAP password. So the user accounts have passwords stored in user password attribute. So this actually kind of brings into something interesting. So previously in the lecture, in this year, we talked about how to crack passwords from the root file. So when you set up LDAP and everything, the user accounts are going to be stored in the LDAP system. So you're going to have to actually, you're probably not going to see them set up in the actually etc password file. So you're going to have to actually pull down the actual file associated with the LDAP. And that's for another time, another course, but that is something to consider when you talk about having to go ahead and change passwords with LDAP password command or having to actually find stored passwords. Now, if you need to connect to the server, it actually has a separate authentication client package called LDAP auth client. You have to install that manually. You have to execute it and tell the system authenticate via an LDAP server, and you have to modify the LDAP.conf file to allow that connection to happen. Okay. FTP. So we're going to talk about FTP, and there are different types of FTP servers you can set up. One of the more common ones is going to be the BSF-TPD, and that's going to be the word of the week, BSF-TPD. BSF-TPD. The default for most major Linux is going to be that one. You also have things such as maybe Pure FTPD or Pro FTPD, that they are either simpler and secure, like the Pure, or you have Pro, which is very user-friendly. It has open call configuration options to the end user. It's highly configurable, so it's actually very helpful. I'm not going to go too into depth into how to install BSF-TPD because that's actually going to be your lab. It's also going to be helpful for you when you actually do it in the actual, in the hands-on piece. So you can connect to the FTP server. You just use the FTP command, and you usually go ahead and type in FTP, and then use the IP address or the host name of the FTP server. And then we're going to get granted with a login account. Now, just like LDAP, you can set up access controls, who can access and who can't, how many connections you can go and set, just like in for the Apache service, as well as also, what you can and can't do. Locking these things down, though, if you're going to install it, the whole point, though, is make sure you lock them down as a security measure, just because of the fact that technically, by default, FTP can be considered to be using anonymous login, which means anybody can log into your FTP server, which means that it possibly may have even read, or even just having read availability is a problem. Then you have a secure shell. So SSH was originally designed to go and replace some of these other types of remote communication protocols, such as Telnet, FTP, RLogin, RSH, RCP, and RExec. All of these are very unsecure. They send everything in clear text. If you're sitting on the wire, you can see everything from the beginning to end. You can go ahead and do a PCAP. You pop it in the Wireshark, you'll be able to find the session, find everything in clear text. So SSH was supposed to help configure that. So what they did is you can actually, SSH by default is already installed, so you already can see that there. So if not, you can install it using, sudo apt-get install sshd. Okay. So one thing you have to understand is that to configure SSH, you have to go into the etc SSH and configure sshd config, not ssh config. The ssh config is used a little bit different when it comes to configuring client utilities, such as, secure copy, secure FTP, or is this SSH? SSHD actually configures the actual process itself, and that way you can go ahead and you can understand the difference. SSHD, the D stands for daemon, which in the Linux environment stands for process. okay, or application. The SSH config actually has to do with how it interacts with other types of client utilities, okay? So there are two different SSH protocols. They're numbered 1 and 2. These are not versions, but rather two separate protocols. Modern SSH clients only use protocol 2. If you want to look at something really, really cool, there was actually a, I believe it was, let me just check to make sure. Something to actually look up, which is actually really nice. It takes advantage of SSH version 1. It's called the Heartbleed bug. And it was basically an exploit taking advantage of TLS, which is the transport layer security, to go ahead and kind of deal with the fact that there actually is it's called the Heartbleed bug for a reason, because you basically bleed SSH keys out. But it's something that you should look it up. There's a really, really interesting technique that has been patched with version 2. So the way SSH works, you use a listen address, okay? So you listen address, and SSH should accept connections on that listen address. So, and usually typically it's gonna be port 22. Other common ports you're gonna see are gonna be things such as 2222, you're gonna see 2223. I would suggest that you go ahead and move away from things such as 22, just because of the fact that people know that 22 is open. Even actually changing it to anything other than 22 is better than keeping it the standard, because it's going to make it a lot harder for people to go ahead and adversaries to identify what the problem is or what the service is, because then they have to actually make a connection. And if they have, let's say, for example, if SSH actually is being mapped to port 2096, that's beyond the 1024. So it's like, what kind of service is that? All right, so you can configure this. You can set the log levels too. This is very important. So this way you can log authentication logs. If there's any errors, if someone tried to connect and you're getting basically a you know, if you're getting a bash with tons of like trying to authenticate to your actual network, you can do password authentication. Excuse me. You can set up a pub key authentication, and these are just different ways you can actually configure the methods. Pub key authentication, you're gonna have to make sure you generate what's called SSH keygen, and that's gonna go ahead and be how it's used to go ahead and, you know, kind of play around with it. We won't be doing that in this class or anything. I may be thinking about adding that in the future, but how to create your own SSH keys and then connect in via SSH. So some of the client commands you can use, you can actually go ahead and use SSH. Again, that's how you can actually go ahead and connect into other workstations without having, that's basically the RDP of the Linux environment, okay? You have the secure copy, which allows you to go ahead and transfer files to and from an SSH server via the command line. And then you also have SFTP, which is a secure version of FTP. So it does SSH with FTP-like commands. So again, you know, these are different. SSH config has to do with the utilities, and SSHD config deals with the actual daemon itself. There's also a system-wide SSH file that applies to all users. That's under etc SSH config. So each user can create a file in their home directory. This is going to be the home directory. Remember the tilde, and then the period. I want to go and make a note that period, if you don't remember, period from the very beginning means that the file is hidden. So you won't be able to see it if you do a normal ls or an ls-tac-l. You have to do an ls-tac-la to get all the files and make sure you get those hidden ones. That can override the settings in SSH config file. So if they have one in their own directory, this can actually override it. Most SSH config file are subsettings of the host settings. So, all right, let's talk about network security policy. So we're talking about things such as modifying the kernel parameters to provide better network security. We're talking about something called TCP wrappers, which some of y'all may have never heard of before. And then we're going to configure the system time manually, and then configure the system to use what's called NTP, a network time protocol. So the first thing we need to do is we need to understand that there's a file called etc sysctl.conf, system control sysctl. Any changes you make will take effect after a reboot. So this is where we can go in there, we can change any information having to do with the kernel. It can be anything have to do with control IP packets, source route verifications. So there are some kernel parameters we can actually edit in here too. These are ignoring ping requests, something you probably should do. Not saying that, you know, it's a thing, but yes, being able to have ping is very helpful when you're troubleshooting networking problems. But if you have no network problems, you should not be able to receive requests. Ignoring broadcast requests. This is also a thing, unless there's a reason why, which there is. There's actually one reason why, and that's going to be ARP. ARP is the only thing that's allowed when it comes to broadcasts. That actually could be the reason why you allow it instead of ignoring it. You can enable TCP SYN protection. So this is actually going to be the SYN protection part. You can also disable IP source routing. So we can actually look at that too. So let's talk about TCP wrappers real quick. And yes, if you kind of don't understand how wrappers work, think of wrappers like an actual wrapper around a candy bar, a piece of food. It's encapsulating, okay? It's encapsulation. And it may be a bad way to describe it, but it's actually what it is. So they're used when server programs compiled with libwrap call that library when a system tries to access that service. So like, for example, the SSH service, the SHD calls libwrap when someone tries to connect to the secure shell service. And what that does, and libwrap uses the host.allow and host.deny to determine permissions. So it can actually go ahead and look at that and say, hey, you can't do that. Oh, and actually, Bob, you're definitely not allowed to do that because you're in the deny file. However, Karen is in the allow file. Yeah, Karen's in the allow file. So we can set up the libwrap for different services. We do what's called an LDD. So we do the LDD command, and we do it under the, and we go ahead and give, we can actually find which ones use it. So let's say we're doing for SSHD, and then from there, once we go ahead and actually do an LDD on SSHD, we then pipe the actual output to grep, which grep we know is to grab the expression, right? Grab the expression where the word is mentioned as libwrap. If libwrap.so.0 is returned, the program uses a TCP wrapper. That's an easy way to go and tell whether or not this program has a TCP wrapper or not. Examples to do grep libwrap and also echo that at the same time. So you may also, there may also be services in the user bin file or the sbin that uses libwrap as well. You can play with this if you want. I'm not going to go ahead. Again, it's not a requirement. So this is how TCP wrappers work. So it's just like almost like a firewall in a way, but it's actually doing some logic checking. So we have the inbound request. It's going to say, hey, does it match rule number 1? If it does, then cool, allow that connection. If not, rule number 2. If it does, well, then allow the connection. If not, then go to rule number 3. If the rule works on the host.allow file, then yes, go over there. If not, then we check the host.deny file, okay? Match rule number 1. If it's yes, then deny. You don't get to connect. However, if it actually doesn't match, then we go to the next rule. We go to the next rule until we either get a connection denied, or if it doesn't meet any of those requirements, then it automatically gets accepted. So this is what's called the implicit, in networking, you're going to hear what's called implicit deny, which is if it doesn't meet any of these rules, then deny it at the very end. Just deny all traffics that don't meet these rules, right? This technically is the opposite of that. This is kind of an implicit allow or accept. So basically, if it doesn't meet these and it doesn't meet these, then we basically get to go ahead and come in. That's why you want to make sure you have that taken care of. So we have the syntax, and this is found in the head CLO. So you have the service list, the client list, and the options. Here's an example. You have SSHD, the client list right here. You have ZynetD and SSHD, the client list right here, and you have all. Yes, you can put in all, and it's going to take that for all services. Okay. NTP. NTP is going to be very important. One of the more important things is going to be making sure that your networks are set up with NTP and making sure that your networking devices have NTP enabled, because that's how they go ahead and maintain themselves. They want to make sure you have an accurate system clock. If your computers are, on the wrong clock and you have an incident, how do you know? How are you going to match up between your other tools and your system? If the system itself is registering 4 hours ahead, or let's say it's registering, let's go ahead and actually let's say it's registering in Russian time, okay? But you're in the United States, let's say they're registering Russian time because someone forgot to change it, and that's what that's what they picked, right? They weren't paying attention. If they have an incident and you get a breach into that server and that server becomes compromised, it's going to be a heck of a time trying to trace back and try to go ahead and match up your other systems to this one system. This is why NTP is very important. You can they can display the system time, but you also need to make sure you set it correctly. So make sure you set the date. On some systems, you can use the time.ctl, so time date control. In ours, you can just do date. You can also use a set time and set time zone, or use set NTP to enable NTP or disable it. So you can do set NTP1 to enable, hence 1, or you can disable it with a 0. You can also just set time zones manually using TZ select. You can also go into the etc time zone file if you're using a Debian system, or if you're using Red Hat or CentOS or something very similar to that, it's going to be a file called etc local time. So there are some symbolic links to a binary time zone file you can actually go ahead and look at too. And you want to make sure that the NTPD daemon is running and that the system clock is in sync with the remote NTP server. You also can configure which NTP server to use. There's actually a very common NTP server that some people use out of like, just for kicks and giggles, called GOAT, the GOAT NTP. So you can also query NTP servers by doing NTPQ, so querying for NTP, list host IP addresses rather than names, or print a list of all peers, and then TACD is enabled debugging. So that's it about NTP and TCP wrappers. Again, this was a very, very short lecture. The next one will be just as short. Again, if y'all work, please make sure you're working on your stuff. The word of the week is BSF TPD. You're good for that one. And then if no other problems, with this, you're good. If you have any questions about your assignment, please let me know. I'm willing to answer questions and just like make sure we can get things done. Again, please make sure you're working on your final one.